Hello, YouTube. All right, so today we're going to be working on some circuit schematic design. So we've got a project that I'm working on where we're basically going to be taking some GPS readings uh, with some other analog sensor data, grouping it together, sending it off to the cloud with like Azure IoT Hub or Avnet, their backend on their backend. So what we're doing today, and I want to preface this by saying I am not a real electrical engineer, but I do have a real electrical engineer dad who has showed me like this is kind of um, so here like we're in Altium. This is where it's at now with the design. We've got our Digi gateway, which is I don't know if you can see it. That's the Digi. It's the IoT LTE gateway. Over here, we've got a u-blox SAM M8 GPS GSM module. And we're kind of breaking up best practices, at least talking with the electrical engineer, is we're going to battery management is going to be over here. Our controller is going to be the heart, the start. Breakout pins over here on the left. And what we're working on now is we are going to work on battery management and power. And what we're doing is we're going to use USB-C to power this with a LiPo battery. And I was asking my dad, I was like, how do I even do this? I don't have the slightest idea. And what you do is you find reference designs. So basically, we go to Adafruit, or there's a couple of different ones. TI has some reference designs and say, hey, you can buy this for $5. USB-C, it's got the battery charger, pretty much everything we want. And the design is right here. So we're going to basically just going to recreate this. So USB-C is pretty cool. We've got V-Bus, which is going to be our power, which says 5 volt, but USB-C can be 3, 5 volt, I think like 14 volt and 20 volt. It's configurable based on CC, CC1 and CC2 values. And it's actually based on like whatever the resistance here is going to configure the USB to draw power. Like you can draw 100 watts with USB-C. It's pretty badass. So to start, we're going to use this MCP738 312, and I have had that copied already. So we're going to just go to Altium, place our part, and I actually want this library, and it's going to be this footprint, I believe. So from Adafruit, so there's that, and we need, you can see VDD is going to go to V-Bus. So VDD is going to go to V-Bus. Where's V-Bus? Okay, so here's V-Bus. This is the USB-C connector, and if we come to our this is the circuit board, this is that, and then we can go to View, 3D. I can't remember how to. Basically, that's our USB. I don't know how to spin it, but so V-Bus. What we're gonna do, we're gonna place net label. So net labels are like variables. V-Bus. V-Bus. So we're gonna connect. Not that one. Place. V-Bus is going to connect to V-Bus, and it's red knowing that it's got to connect. This is how you connect 2 wires. So we're going to place another one, net label, V-Bus here, and it's saying V-Bus goes to VDD. Boom. Okay, so now V-Bus, VDD. So, and then VDD, there's going to be a 10 microfarad capacitor. And that is going to be going to ground. And I'm assuming that's for like noise like acting as like a filter, as a guess, as a non-engineer guess. So we'll put it on this side. I think we can just come up top, part. So we're going to go to our parts. We're going to look at all, we want a capacitor. And choosing parts is like the hardest part of this, I find, because I mean, I'm just copying reference designs. So chip capacitor, 1 farad, microfarad. I mean, let's see, not that one. So we need a 10 microfarad. So here's a 10 microfarad. Yeah, that works. And we'll hit spacebar to kind of rotate that around. So here's our 10 microfarad capacitor. And we need this to go to ground. So place wire. So we got our 10 microfarad capacitor. So there's that leg. VDD. Stat also goes, it looks like stat is going to go to ground, and it's also going to go to VDD. So I'm assuming that's like the status of it. So let's get our 470 ohm resistor. Wait, where's going to stat? Stat. So stat is going to junction. So stat's going to go 470 LED, which we're going to skip for now. We'll skip for now. 470. Well, I guess we don't even need that then. So these, for now, we're going to skip this. This is for the signaling lights. So this is going to be red when it's, I think, not charging, green when it's charging. I don't know. We got to look into that. So if we come over here, this is the JST battery. And it looks like pin 1 is going ground. Pin 2 is going to VBAT. I have it flipped in my... So pin 1 goes ground. So let's put that here. Put that here. Okay, and make sure, yep, they're connected. So pin 1 goes to ground. Pin 2... So pin 2 is not VCC, actually. Pin 2 is, we're going to call it VBAT. So let's place VBAT. Okay. That's cool. So VBAT is going to go to VBAT in VDD VBAT. So here, net label. So this is going to be VBAT. Okay, so we got VBAT. Oh, sorry, wrong one. So VBAT is also going to get, I believe, a filtering capacitor. So it's going to be 10 microfarads down to ground. And that's into this chip. So what we can do is steal this here, and we're going to ground with that. So let's grab another ground. Here, place some wires. Our squiggly should go away. I think I'm connected. Yeah, so I'm definitely connected. I don't know. That should go away. I don't know. We'll see. We'll do some validation. Actually, maybe not. Oh, it's duplicated designator. Okay. So now we've got our VBAT. Progress, we have, I don't know what this thing is, this little, I don't know what the heck that is. VSS is easy. Whatever VSS is, we go to ground. So there's VSS. So let's steal a ground. And we'll go place wire. VSS goes to ground. So VSS goes to ground. Progress is split. So we have a voltage divider circuit. I think it's a voltage divider, but they're in parallel. Okay, so progress. So we need a resistor. So let me capacitor, resistor, and wrong window. We need a 10K ohm resistor. 10K. And I don't know, like, we probably want surface mount. Yeah. I think we can look at our footprint. Yeah, so that's our footprint. It's surface mount. So we need a 10K ohm and we need a 2.2K ohm. So I'm pretty sure it's a. What was the other one? 2.2K. Cool. So progress is going to come out, and we're going to go parallel 10K, 2K. So progress is going to, basically progress is going to go to 10K, I think. Place wire. And then these guys touch and go down to ground. So we'll have another ground. Here. And then I think we just touch these. I think. Place wire. And then this, again, we got a designator issue. R1. I think there's a way to automate that. This one's going to be R2. Cool. Okay. R2 VSS goes to ground, so got that. VBAT, that. Okay, so then the other thing we need to do is, I think so the CC pins are configuration pins for USB-C, and it's going to be what sets what voltage and amps you want because it's configurable. And so you can see 5.1K ohms on C1, C2 to ground is what we want. So here's CC here. So let's do CCC2. This is going to be CC2. Not a part. We don't want a part. We want CC1. Let's put some wires in here. So blue, something that got me, you want to make sure blue is the connecting point, so make them blue. So then over here, so I think at 15 minutes, this might just shut off. I hope not. Ah, it's still going. Cool. Okay. So CC2 5.1K ohm. 5.1K. K. 5.1K. Maybe there's not. There's 5. Is there a 5K maybe? 5K. It's probably pretty close. Or resistor 5K. I think this is 5.6K. That's pretty close, I would say. I'm going to triple check with Engineer Dad that that is correct. So this is going to be properties. This will be a resistor 3. Oh. Oh yeah, you can change these values. Maybe not. Hold on. That'll mess up your bill of material potentially. I was thinking, I think you can just, so I think like, maybe not. I can change the value to 5.5K, but I don't know, like, if I just leave it this, I can have it manufactured easier. 5.1K, I'll see whatever. Well, it's 2 of these. CC1, CC2. So again, we're setting up that USB-C configuration, and then we're going to come down to ground. Place wire. Where's the side? There we go. Blue, 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 blue. Okay. So that's looking pretty cool. I might move this down a little bit. Cool. Stat. Sorry. Oh yeah, there's stat. Oh yeah, stat. Wait, stats for the status of things. We're not gonna mess with that for now. And then the other thing. So this is gonna be it for this video. I'm gonna just do one thing real quick. Design update PCB. Continue. Execute changes. And then I need to go view to 2D. So in the PCB layout, I'm not even doing just doing schematics right now. Basically, now we have all these other passive components we need to add to our board. So, I mean, for me, this is getting pretty complicated, pretty cool. So this here, LTE IoT radio, power, U-Blocks GPS module, and battery. Pretty simple for my first board. Well, actually, it's not my first board. Cool. All right. Well, that's this time. We're going to hopefully in the next video keep pushing this out and making this more and more into an actual thing. So see you next time.